We were doing construction of grammar language. One question we did, integrate all parameters. The least palindromes are epsilon, A and B. So whenever you are a grammar, we need to take S and take the least productions as directions. Means yes, these things as direct productions. S there is A, S there is B, S there is epsilon. And we want the remaining all these palindromes. So for that, S there is ASA and S there is BSB. Okay. So finally, this is the grammar. I think we have done this question yesterday. Yes or no? We completed this question.
Yes,
Hello,
sir.
please respond. Okay. So S is the start symbol and only one non-terminal. A and B are the terminals, and S the non-productions ASA, BSB, A and B epsilon. Now the question is Wcw transpose means W can be any combination of A and B followed by C, and C before whatever, C after it must be exactly reverse order. So here the smallest string of W is W belongs to A and B whole star. So the least string of W is epsilon. If W is epsilon, then C epsilon transpose is epsilon. So here the string can be epsilon C epsilon, which is C. So the smallest string is C. So I told you, go take the production, the smallest string. Here S is the start symbol and the smallest string is C. So S is one production. And whatever suppose W is ABB followed by C, and C after it should be the reverse of the ABB, which is this one. So here whatever we have, it must be the reverse of this one. So here this is A and B, combination of A and B. So okay, and this is reverse. So combination of A and B and reverse. So here I told you the symbol before and after, here A and this S before and S after, both are same. And here the string is of for A and B, therefore BSB, the symbol before and after. Same. So this is the grammar. So what is the grammar finally? Only one symbol, non-terminal S, and the terminals are A, B, C, and the productions are yes, there is ASA, ESB, and C. Okay. Here we should not take epsilon. As there is epsilon, we should not take. If I take as there is epsilon, then epsilon will be the smallest string. But if, what is the smallest string here? When this is epsilon and this is epsilon, the smallest string will be C. So that is the reason I am not taking as there is epsilon. Okay, only as there is ASA, BSB, and C, and S is the start symbol. This is the grammar. Copy this. Here, every time, what is the least value of n? N is 0. If n is 0, then epsilon is the string. If n is 1, n is 2, n is 3, n is 4, N is 5 like that. So the language will have these strings. And epsilon. So epsilon is the smallest string. I told you, take the smallest string as a production. Yes, there is epsilon. And we want the remaining. So for that, take AS. See, look at this. Yes, there is AS. In S place, if I take epsilon, then you will get A. Otherwise, in S place, if I take AS, then S place epsilon, then you will get A square. Or in S place, instead of epsilon, take AS, then epsilon A cube. So the grammar for this A, only A is the star terminal and S is the non-terminal. And the productions are AS and epsilon and S is the star symbol. Copy this. This one A power 2n. A power 2n. What is the smallest value of n is 1. If n is 1, it is a square. N is 2, a power 4. N is 3, n is 4, n is 5. So it will have even number of a's. And the smallest string is double A. And the remaining string for that ASA. This is the grammar. Okay. So these are the productions. And the grammar will be S is the only non-terminal. And A is the terminal. And productions are already put here. And S is. Hello. You can write the portion like this also. Double A is the small string and double AS. Okay. So this is also correct. Instead of ASA, you can write double AS. That's it. Now, next one. So next time onwards, I don't write the complete structure of the grammar. What are the terminals? What are the non-terminals? What is production steps? So directly, I write the productions here. Okay. So what I'm saying is, next time I don't write this. Means what are the non-terminals? What are the terminals? What is start symbol? So by looking at this, you will understand. So only production I will write. Next, A power n, B power n. Tell me, here what is the smallest string? N is 0, then epsilon. N is 1, N is 2, N is 3, so on. So here the smallest string is epsilon, and here A's and B's are equal. So whenever we generate A, generate B, that's it. Whenever we generate A, we generate B, this is the grammar. Doubt? Hello? Are you there?
Yes, sir.
Okay, next one. Copied. So here I am not writing. Okay, let me write this complete grammar. S is the non-terminal. A and B are the terminals. And the productions are ASD and epsilon. And S is the start symbol. Okay. Now for this, What is the grammar for this? Hello. The smallest thing is epsilon ab square a square b power 4 a cube b power 6 a power 4 b power 8 so on. So the smallest string is epsilon. Here the b's are double 2a's in every string. Here a and 2 b's, 2a's, 4 b's, 3a's, 6 b's. So b's are double 2a's. So whenever you generate one a, then generate 2 b's. This is the number. That's it. Any doubt? A power n, b power 2n. The minimum value of n is 0. N is 0, then epsilon. N is 1 ab square. N is 2a square b power 4. A cube b power 6 like this. Okay. So the number of b's are double 2a's. And the smallest string is epsilon. That is the reason s there is epsilon. And here in every string b's are double 2a's. So for that reason, whenever you are generating a, for every A generate 2 b's. So that is the reason I took S there is AS double B. So the productions are S there is epsilon and S there is AS double B. This is the grammar. Do you understand? Hello?
Yes, sir.
Report to N?
Yes, sir. Yes, sir.
Okay. Copy this one. Next. Try this one. L6. A power m, b power n, where m comma n greater than or equal to 0. Anybody give me the answer for this one? Anybody?
S derives to ASB slash AS slash BS slash A slash B epsilon.
फिर से बोलो.
ASB slash AS slash BS A slash B slash epsilon.
Okay. However we apply the productions, we must get the only valid strings. It should not give any invalid. At the same time, we must get every valid string. What is the language here? Any number of A's followed by any number of B's. Okay, A's and B's may be equal or unequal. Here, as per your productions, I will take BS in the starting. After that, in S place, I will take AS. Then in S place, this time I'll take BS, then AS, then BS, then AS. So you are getting B's followed by A's followed by B's followed by A's followed by no. What is the language here? Any number of A's. A's can be any number followed by B's. That's it. B's can be any number. So after B again A should not come. So this is not correct. समझ गए ना मिस्टर?
Yes, sir.
हेलो मिस्टर.
So फिर टर्मिनल स्टेट में एस ए एंड बी
Anyone
रहेंगे क्या?
else? बोलो.
सर टर्मिनल स्टेट फिर एस ए एंड बी रह सकते क्या?
फिर से बोलो यार. आपका मर्जी. नॉन टर्मिनल्स. Or terminals. What else are you talking?
सर नॉन टर्मिनल्स.
Terminals are A and B only. ले लो.
Sir, but जब m की वैल्यू जीरो होंगी तो a to the power 0 मतलब epsilon into b.
Then B.
b
B, only B's can be there. Only A's can be there. Only A's can be there. Only B's can be there. If M is 0, then only B's. If N is 0, then only A's. Or any number of A's, what be any number of B's.
Yes, sir. So, B square strings will be there, no, sir?
Hmm?
B square, B cube strings will be
What?
there. B square, B cube.
Only B's. B, B power 4, B power 5, B power 6, so on. Similarly, only A's. A square, A cube, A power 4, A power 5, so on. Only A's and only B's or any number of A's, what any number of B's can be there.
Okay, sir.
Will be there. Sorry. Shreya, answer for you.
Sir,
Shreya, our girl. So, can you speak Malayalam?
sir,
Shreya ji.
yes, sir.
Okay. For you. Answer. You tried or not?
Yes, sir, but I didn't get the final answer.
Okay. Simple, guys. Simple. I will use capital A to generate A power M. I will use capital B to generate B power N. Okay. Guys, suppose A is the start symbol and if its productions are AA and epsilon. Now tell me, what are the strings this A can produce? One is epsilon, yes or no? And AA, then A plus epsilon, you will get A, okay? Or A plus AA, again A plus AA, then epsilon, you will get A square, or again AA, then epsilon A cube, or again AA, then epsilon A power 4. So this will give only S from 0 to any number of S. That is epsilon A square, A cube, so on. And similarly, let B is the start symbol. So just forget about the A. And if B is the start symbol and B, if B's portions are these, then what are the strings? It can give epsilon. You take BB, then B plus epsilon, it will give B. Or you take BB, example this one, BB, you take BB. And in B place, you take again BB, then B plus epsilon, you will get B square, or in B place again BB, then epsilon, you will get B cube. So this will give B power N, and this will give A power M, this part, and this will give this part. Okay, but what do we require? Yes for B's. So for that reason, here I will take one start symbol, that is S, and S production is A followed by B. So we start with S, and S there is AB. In A place you substitute epsilon or A epsilon, you get S, and B place you substitute epsilon or B then epsilon. So this will give S and this will give B. So this is the simple grammar. समझ गए ना?
Yes, sir.
Hello, huh? Can anybody give the better answer for the same grammar? Sorry, for the same language, can you give a different grammar better than this?
S derives to AA slash BB slash epsilon.
Disable?
S derives to AA slash BB slash epsilon.
No.
Sorry, S derives AA slash epsilon, and then B derives BB slash epsilon.
Hello. If these are the productions, what it can generate? What are the strings it will be? This grammar will generate. Bol.
Epsilon A square.
A square, A cube, so on. That is only S. Suppose, guys, if these two are the productions, then what are the strings can be generated?
epsilon b, b square, and so on.
Epsilon B square D. So this is for only S and this is for only base. I want S for the base. So what I do? I will club these two. That is AS, BS, and epsilon. So this will give only S, only B's, S for the B's, and also unwanted strings. Like I will start AS, then S place BS, then again S place AS, then BS, then AS. So it gives all the combination of A and B. No, we want only A's for B's. We don't want the strings like this. This in okay, or this one. We don't require all these strings. So, but these two alone gives only A's. These two alone gives only B's. If I club these two, it gives valid as well as invalid. So what is the solution for this? For this, just I am changing this. Simply look at this. Guys, tell me if these two are the productions, what are the strings can be generated? Look at this. I will take as B. In S place, if I substitute epsilon, then it will be B. Or in S place as B, then S place epsilon, it will be B square. Or in S place SB, then S place epsilon, it will be B cube. Or SB, then epsilon B power 4. So it will give only S and it will give only B's. Now what I do, I will club these productions. That is AS and SB and epsilon. Now this gives only A's and only B's and A power M, B power N also. Let us check. Okay. Now this is the grammar. See, if I use these two only, I will get only A's. If I use these two only, I will get only B's. If I club these two, let us start with AS or SB. Now in S place AS. Now again S place AS. Now S place BS. SB. So yeah, however you use AS or SB, AS comes before S and B's comes after S. There is no chance of mixing A's and B's. And finally, S will be replaced by epsilon. So this gives this language. Okay, this language. So compared to this first method, this is the best one, because here number of productions are less and number of non-terminals are less. Whereas in the above one, we have 3 non-terminals. In this one, SAB, 3 non-terminals and productions are 5. Whereas in this, only 3 productions. Okay, you understand? Any doubt? Hello? Okay, na?
Yes, sir.
Now, here, this is A's followed by B's. And here, next question. This is also A's followed by B's, but the number of A's must be greater than number of B's. Suppose, if A's are 10, B's must be minimum 1 and maximum 9. So, when A's are 10, B's must be minimum 1 and maximum 9. So, 1 B's can be 1, 2, 3, so on. Or I can say like this. When B's are 9, then how many A's should be there? If B's are 9, how many A's should be there? Tell me.
Greater than 9.
Minimum 10. Very good. Minimum 10. Can be 11, can be 100, can be 1000, can be 1 lakh. So, however I substitute, the number of A's must be greater than the number of B's I should get. Anybody give me the answer? Hello? What is the least value of n here?
1.
Very good. If n is 1, that means b's are 1. Then how many minimum a's?
2.
2.
2.
So this is the smallest string. Okay. Now, if this is the grammar and the smallest string is AAB, if this is the grammar, what is the language that can be generated from this grammar? This is the grammar, what is the language? Hello? From this, you will get equal number of A's and B's. Let us check. In S place, we will take A as B. In S place, if I take A as B again. In S place, if I take A as B again. So, the number of A's before S and number of B's after S always will be same. Okay, if I substitute again A as B, then A power 4 S, B power 4. Again A as B, then A power 5, B, S, B power 5. And finally, S will be replaced by AAB. So this is the language string A power 5. Sorry, this is BQ. A power 5, B power 4. So this will give the language A power n plus 1, B power n, where n greater than 0 means the smallest, the least string is AAB, and this grammar gives only one extra A than the B's. That means when B's are 9, it will give A power 10. When B's are 100, it will give A power 1, A is 101. When B's are 1 lakh, it will give A's are 1 lakh plus 1. Okay. But when B's are 9, what is the language required here? When B's are 9, you must get A's 10, 11, 12, 13. Okay, or A power 100, B power 9. All these things I want. I want A power 100 and B power 9. From this grammar, you cannot get this. When B's are 9, you will get only A's are 10. Or when A's are 100, you will get only B's are 99. But you don't get, when A's are 100, you don't get B's 1 to 98. You don't get these things. These things you don't get. Okay. So this grammar won't give all the strings of this language. So you just, what shall I do to get all the strings of this language? Are you following?
Yes, sir.
Can you give the solution for this? Tell me. This is for equal number of A's and B's. Okay, this is for one extra A, but I want more A's. That means this grammar will give, when B's are 9, it will give A power 10. Or I can say like this, when A's are 10, it will give only, huh?
हम
क्या?
AS ले सकते क्या?
Yeah, that's good. That's good. Guys, listen. This is for this is for equal number of A's and B's. As long as I go for this A S B, it will give A's and B's equal. But I want more A's, one extra A, then I will go for A's. I want two extra A's. If I substitute two times A's two times, then A's will be two more than the A's. If okay, as many times I substitute, look at this, A's, again A's, again A's. As many number of times you substitute, that many A's will you get more, and yes, you will get ASB. And as long as I go for ASB, 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 this will give equal number of A's and B's. And finally, S will be replaced by AAB. So this is for equal. And even though you don't go for this production, and when you replace S by AAB, minimum 1 A guarantee, you will get an extra. If you want more A's, then go for AS. So however you substitute AS, then ASB, or again in this place, suppose in this place, already these are 5 A's. Okay. And now I substitute AS, already this is B square. Now ASB or AS. So you will get A's first, then S, then followed by B's. There is no chance of mixing A's and B's. And finally, S will be replaced by AAB. So I repeat, this is for equal. This is for only one extra A. And this is for more number of A's. Even though you don't come to this production, this is for equal. This is minimum 1 A extra. So the grammar is this one. समझ गया? Any doubt?
Yes, sir.
Doubt है?
No.
Doubt क्या?
No, sir.
No. Doubt means you are saying yes. Okay. Simple grammar. Copied?
Yes.
Now. Take this question. If G equal to S, AB are the not terminals, small ABC are the terminals, productions S start symbol, and productions are given. Here B is B, C, and C. And A is AAB and epsilon. And S derives AB. Then what is L of G? Tell me the answer.
सर शायद नन होगा।
नन है तो क्या आंसर है?
सर एक्चुअली जो स्मॉलेस्ट जो स्ट्रिंग होंगी वो सी रहेंगी ना। तो सर ये ऑप्शन में
So
तो
what is the
नहीं
language
है।
then? Language क्या है?
नहीं सर मैं मतलब ये देख के ऑप्शन नन बोला था, लैंग्वेज नहीं बनाया अभी तक।
बोलो। Answer?
Answer may be A, sir.
What?
A.
A.
Yes, sir.
श्रेया आपका? श्रेया जी आपका आंसर?
Sir, trying on the grammar.
Yes,
Sir.
there is A, B. Every time go for the smallest one. Okay. And from this A, B and epsilon. So through A, epsilon, A, B, A square, B square, A cube, B cube, A power 4, B power 4. Do you agree for that? A derives A, B. If I substitute epsilon, then A, B. Or in A place A, B, then epsilon A square, B square. Or again in A place A, B, then epsilon A cube, B cube. So through A, you will get A power n, B power n. And what is the smallest string here? A derives epsilon. So epsilon is the smallest string. So here n is greater than or equal to 0. And through B, so the smallest string is C. Or you take BC, then B plus C, you will get C cube as a C square. Or in B place again BC, then B plus C, C cube. Or again B plus BC, then C, C power 4. So the strings from B are C, C square, C cube, C power 4, so on. So here I am writing C power M. And M is minimum 1. Okay, so M is greater than or equal to 1. So this is the language. So A power N, B power N, C power M. So everybody will see this one and you will go for this option, which is wrong because here the conditions are wrong. N come. Okay, here N is greater than or equal to 0 and M is greater than or equal to 1. So that is the reason. Okay, and B is not matching, C is not matching. So answer is none. Answer is none. And class లో ఉన్నా చెప్పేయండి. Okay. 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 So finally, the language will be A power n, B power n, C power m, n greater than or equal to 0, and m is greater than or equal to 1, or m is greater than 0, whatever this is. But this is not given. Okay. Do you understand?
Yes.
Guys, tell me. Try one more question. Say yes or no.
Yes, sir.
S is S derives 0 S0, S derives 1 S1, S derives 2 A3, and A is 2 A3 and 3. Find L of G. Do you want options or will you try without options?
Options, sir.
Try this.
ఇది కార్ మోడల్ ఏంటి కార్డ్బోర్డ్ ఇవన్నీ కార్డ్బోర్డే
Good. Very good. How is it? Idruna?
Third option.
Third one.
C. Third.
Okay. Angel, close
Yes,
the door.
sir. C option.
Okay. Good. C is the right answer. Very good. Every time, whenever a grammar is given, check for the smallest string. Here, these are the S productions. S0, S0, 1, S1. Again, S is generating. So that is the reason we will go for, actually S productions are 0, S0, 1, S1 and 2A3. And A's productions are 2A3 and 3. So first we will go for 2A3 because 0S0 and 1S1 in these two productions S is there. So I'm going for 2A3. And in A place, if I substitute 3, then this is the smallest string. Okay. Or S place, take 2A3. And in A place, 2A3, you can take this production, 2A3. And again 2A3, suppose. So 2A3, 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 as long as we go for this production, the number of 2's before A and number of 3's after A will be same. So this will be 2 power n, A, 3 power n. A before number of 2's, A after number of 3's will be same. And finally, to eliminate A, you must substitute 3. And this is the language, 2 power n, 3 power n plus 1. Here, the least string is 233. It's 2 power 1. So, 2 power n, 2 power 1, n is greater than 0. This is when we go directly to 2A3. S has 2 more productions. Zero S0 and 1 S1. If I go to 0 S0 or 1 S1, this time again I'll go for 0 S0. And this time I'll go for 1 S1. And again I'll go for 1 S1 or 0 S0, whatever. So as long as you go for 0 S0 or 1 S1, just look at this. Whatever S before and S after, it is reverse. Here 0010 and it is 0010 in the reverse order. So S before, it can be any combinations of, see, instead of 0 S0 in the starting, you can start with 1 S1. Then you can take 0 S0. So like this, S before, it can be any combination of zeros and ones followed by S. And after S, it will be reverse of this previous S, W. And to eliminate S compulsory, you have to come to this 2A3. So S can be replaced by 2A3. And from A, you can get this one. So from A, you will get 2 power n, 3 power n plus 1. And W transpose, where W is any combination of zeros and ones and n is greater than 0. This is the language. Do you understand? Okay, so check for the smallest one. This is the smallest one. Okay, after that, S place 2A3, 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 you will get this one if you go directly to A3. Or if I go for S0, S0 or 1 S1, as long as I go for these productions, S before whatever, S after, it will be reverse. So S before, it can be W, the combination of any combination of zeros and ones, and S after, it will be reverse of W. Okay, and to eliminate S, you must substitute this production. If I substitute that production, you will get this final answer. Okay, now, so C is the right answer. Do you understand?
Yes, sir.
Hello.
Yes, sir.
Guys, okay.
Yes, sir.
Copy this.
Yes, sir.
Copy this one. A star means on several after applying several productions, the production several times. Okay, that's all about the grammar. We have completed the grammar. If you want to do, anybody have tried the questions? Okay, you have the question with you now. I will tell you one question. You just try. Question number 93. Hello guys, question number 93. It's easy question. Please try this question number 93. Question number 93, then 99, 101. 93, 99, 101. You please try all these questions. Hello. అదే నాకు సీన్ చెప్పాడు. నెక్స్ట్ వీక్ ఎప్పుడు? సండే ఈవినింగ్. అది నెక్స్ట్ వీక్ పెట్టుకోవచ్చా? ఎక్కువ ఉంటారు కదా. అయితే నెక్స్ట్ వీక్ అలాగా నేను వస్తాను ఆఫీస్ని. సరే, మర్చిపోకనే. ఓకే, నేను క్లాస్లో ఉన్నాను, మళ్ళీ వస్తాను. ASB BS and epsilon. S derives AS. S derives AS, BS and epsilon. Guys, if I use these two productions only, means I will get S derives epsilon, S derives AS, then S plus epsilon, I will get A. Or go for AS, again S plus AS, then S plus epsilon, you will get A square. Or in S plus AS, then S epsilon, you will get A cube, A power 4. So from these two productions, you will get A epsilon, A square, A cube, A power 4, A power 5, A power 6, so on, only S. If I take these two only, means epsilon, then B square, B cube, B power 4, B power 5, only B's you will get. Okay, if I club these two productions, all these two, means all these three productions, if I can take example, I can start with AS or BS. I will start with AS, then S plus, I will go for BS. And again BS, like that, or again AS, again BS, again AS. So it is any number of S for B, any number of B for B, any number of B, again BS, again BS, and finally S will be replaced with epsilon. So it is, or you can start with BS, then again AS, then again AS, or BS, AS. So it gives only A's and only B's and all the combination of A and B. So simply the language generated by this grammar is any combination of A and B. Any combination of A and B. That is, this is A plus B whole star. It is not A, because A is only A followed by B's, and B is equal number of A's and B's. No. And C is A power and B power and A power and B power and no. It gives all the combination of A and B, which is option D. Do you understand? Hello?
Yes,
Yes, sir.
Easy question. Why didn't you answer? Any doubts?
No, sir.
No,
Okay,
sir.
then next question. Do you want to copy this? After that, 93 after 99. This 99. He has given productions and which where S is the start symbol variable, then which one of the following strings is not produced by the grammar. He has given some grammar, STRS, SAS, ASB, BSA and SS and epsilon. He has given 4 strings. Out of those 4, which will not be produced by the grammar? So tell me, remember these things, you tell me, I will write. This is the grammar. And strings are, can you say the strings, guys? What are the strings? AB, AB, triple AB. A double B A. BA BB. What is this? Yeah. BA BBA. Okay. Okay.
Sir, last
Out
option
of
होगा
these
शायद.
4 strings, BA BBA. Okay, look at this. BA BBA. BA BBA. Okay, na? BA BBA. So try this one. Okay. So out of these, which will not be generated by the grammar. Okay. So try this. Krishna. Krishna. Yeah, always.
Sir, option D.
Sir, option D.
Option D. Okay, good. Actually, we can answer this very simple. First, observe the grammar. Instead of trying every string, whether it is generating or yes, it is generating, yes, it is generating, yes, it is generating, yes, it is not generating, okay, this is the answer. Instead of going for checking every string, observe the grammar. Here, the productions are S derives A S B. Here, whenever A is generated, B also be generated. So, whenever A generated, B also be generated. So, A's and B's are equal. And BSA. In this production also, whenever B is generated, A also will be generated. So, B and A's are equal using this production. And using this production, A and B's are also equal. So, here A's and B's are equal, here also equal. And SS, so here also equal. And epsilon, here also equal. And look at this first production. Here, we are producing only A. In here, in S place, suppose I am taking SAS. In S place, again I substitute SAS. Are you following? So here, using this production, there is a chance of getting number of A's more than the number of B's. I repeat, this gives equal A's and B's. This also gives equal A's, number of A's and B's. And here no A's and B's. Okay, leave it. And here also epsilon means A's and B's are equal. But when you generate, when you use this production, when we use this production, there is a chance of getting A's more number than the B's. So however we use these all productions, either A's and B's are equal, okay, with this equal, with this equal, with this equal, with this equal. But if you come to this one, if whenever you use this production, so definitely A's will be more. So from this grammar, either A's and B's are equal or A's more than the B's. Here A's and B's are equal, chance is there. Here A's are more, chance is there. Here A's are more, chance is there. But here B's are 3, A's are 2, which is never. BA, BBA, however you use this, it cannot be generated, because here number of B's are more than the number of A's. Here it will give equal number of A's and B's. It is equal number of A's and B's. Here equal number of A's and B's. Here equal number of A's. This is A's will more than the B's. There is no chance of getting B's more than the number of A's. So this string never be generated. So this is the string which cannot be generated by the grammar. Do you understand? Hello.
Yes, sir.
Okay. So instead of checking every string whether it is generating or not, I have done this, verified. So I have analyzed the productions. The productions can give either equal number of A's and B's or more A's than the B's. There is no way of getting more B's than the A's. समझ गए ना?
Yes, sir.
Yes, sir.
Okay. Guys, next 101. Question number. You have na? You have this question with you. So try that. This is the question. Actually, here in 101, the option C and D, context free but not regular. So you don't know what is context free. And in D option, recursive. You don't know what is recursive and context free. So just leave this C and D. You just check for A and B, whether A and B are right or not. So if A and B are not correct, then we so leave the answer, because you don't know what is C and D. ASB, CT.
Sir, B.
Not finite but regular. Okay, guys, good. Here, yes derives A as B and T G1 is S derives A, S, B or T and T derives CT or epsilon. Okay, what is the L of G here? L of G1. As long as I go for ASB, 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 the number of A's and B's will be equal and you will get S. To replace S, you must come to T. And from T, it will be epsilon or CT, 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 CT. So A power N, C power M, B power N. Okay. Here, S derives ASB. Instead of ASB, if I go directly to T, then T can be epsilon or CT, CT, CT. So here A's and B's can be 0 and C's also can be 0 if I go directly epsilon. So N comma M greater than or equal to 0. Okay, this is the language. And here this language can generate only C's also. See, S, I don't go to this production. I'll come to S derives T, then T plus S derives T plus CT, 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 CT. So in place, you will get only C's, where M can be 0, 1, 2, 3. Okay, this is L of G1. And what is L of G2? This is G2. Okay. G2 is this one. S derives BSA or T and T derives CT or epsilon. Okay. Here S derives BSA and in S place again BSA, 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 so on. So the number of B's and number of A's will be equal. So B power I, S, A power. To eliminate S, definitely you must come to T. And through T, you will get epsilon or CT, 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 CT. So C power J, A power I, where I comma J greater than or equal to 0. Why? If I go S directly to T, then T can be epsilon. If I go S directly to T, from S to T, I don't get A's and B's. That is the reason I is 0. And in T place, I can go for epsilon or I can go for CT, 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 CT. So you will get C power J, where J is greater than or equal to 0. Okay. So this is the language. Here, what is, this is L of G2. L of G2. L of G2 is B is followed by C is followed by A's. And whereas L of G1 is A is followed by C is followed by B. So there is no common strings of L of G1 and L of G2, including A, B, C. Here A is followed by C is followed by B's, whereas G2 is B followed by C is followed by A. So there is no common strings in this, and in this. But what is L of other one? This is L of G1. L of G1 can give you only C's. At the same time, L of G2 also can give only C's. So L of G1 intersection L of G2, these both can give only C's. So the common strings will be C power K, where K equal to K greater than or equal to 0. So this is here C power K. What the smallest string is epsilon. Then C square, C cube. This is the automata. So L of G1, L of G2 is regular. This is regular. And it will have infinite. C power K, K is greater than or equal to 0. Means the strings are epsilon, C square, C cube, C power 4, so on, infinite. So it is regular and infinite. Do you understand? So it is regular
Yes, sir.
and infinite. Okay, copy this one. So answer is, what is the answer? B. Not finite but regular. B is the answer. And here L of G2 is B power I, C power J. At the same time, we can get this also. So L of G1, G2 is epsilon C, C square, C cube. So it is regular and infinite. Okay. Now we'll go for new topic. Any doubts?
No, sir.
Okay. Grammar gives language. So what is grammar? Grammar is set of rules used for deriving the language. So grammar gives language. There are different types of languages like regular, context free, context sensitive, and recursive, recursively enumerable, like this. So all these languages are defined. I repeat, language can be defined based on the grammar. That means regular grammar gives, I repeat, grammar gives a language. So the language will be defined based on the grammar. So the type of language will be defined by the type of the grammar. So if a grammar is regular, then the language produced by that grammar is regular language. If a grammar is context free, then the grammar will give context free language. So the language will be defined based on the grammar. And the grammar will be defined based on the production. I repeat, language will be defined based on the grammar, and grammar will be defined based on the production. And there are 4 types of productions. Type 0, type 1, and type 2, plus type 3. Okay. So the language will be defined based on the grammar, and the grammar will be defined based on the productions. And there are 4 types of production: type 0, type 1, type 2, type 3. What are these 0, 1, 2, 3? I don't tell you now. I'll tell you at the end of the subject, after finishing the Turing machine. Now, We are talking about context-free languages. This is the chapter, new topic, context-free language. So here we will talk about this type 2. What is type 2? Okay. So the language will be defined based on the grammar. So what is type 2 grammar? The type 2 grammar is context-free grammar. So what is a context-free grammar? Just now I told you the grammar will be defined based on the types of the productions. A grammar is nothing but productions, set of productions. It will have production like this. Maybe 1 to P1, P2, P3 like this. There will be some n productions. Okay, these are the productions. Here in the grammar, if every production is of the form A derives alpha, if every production of the grammar, if every production of the grammar is of the form A derives alpha, I repeat, if every production in the grammar, if the grammar is having 100 productions, all 100 production must be in this form, where the meaning of this is the left side of the arrow, it must have only one symbol, that too non-terminal. On the right side of the arrow, anything, there is no condition for the right side of the arrow. It can have only non-terminals or only terminals or both combination, or it can be epsilon. Only the thing is, whatever the left side of the arrow, there must be only one symbol, that is non-terminal. Okay, so copy this one. Copy this if you want, otherwise you can leave this. Anyhow, I'll tell you this at the end of the syllabus. Take the heading context-free grammar. Context-free grammar. If every production in the grammar, if every production of the grammar is of the form A derives alpha, where A belongs to V and alpha belongs to V and T whole star. You can see on the screen. Is said to be context-free grammar. Is said to be context-free grammar. Next. Context-free language. Guys, already I told you grammar gives language. So the language generated or produced by the context-free grammar is called as context-free language. Copy this one. The language produced by the context-free grammar is called context-free language. Okay. Now we see the example. The left side must be single. Right side can be anything. So look at this grammar. Here S, A, capital S, capital A, capital B are the non-terminals and small a, b are the terminals. Here in every production, here we have 5 productions. Here the left side is single. Left side is single non-terminals. Left side is single non-terminal. So this is quantity free grammar. Okay. From this, I will derive one string. Look at this, S derives AB. And after this, we can apply a production in either A place or we can apply in B place. Okay. I am applying in A place AA. Now, I will apply in B place. In B place, I will apply B. Now, in A place, I will apply this A production. A has 2 productions, and B has 2 productions, BB and B. So, in B place, I have substitute here B. In A place, I have substitute. So, this is AAB. So, I repeat, S is the start symbol AB. After this step, you can apply a production in A place or B place. First, I applied in A place AA. And now, in this, you can apply in A place or you can apply in B place. I have applied in B place. Now in A place. So we got this AAB. Whatever the string we have derived, that string we can repeat. Whatever the string we have derived, that derivation we can represent using the trees. First we have taken S. And in S place, we have substituted AB. After that, in A place, we have substituted AA. After that, in B place, we have substituted B. After that, in A place, we have substituted A. So, this is the tree for this derivation. So, this tree is called a parse tree or derivation tree. Look at this. In this, if you take the leaves from left to right, this is A, B. Take all the leaves from left to right. That is AAB. AAB is the string for this tree. Okay. So the derivation, whatever we do, that can be represented using trees. Those trees are called as parse trees or derivation trees. Copy this. And string will be from left to right, taking all the leaves, leaf nodes. Copied, guys? Hello?
Yes, sir.
Yes, sir.
Okay. Okay, and next, leftmost derivation. Leftmost derivation. The same grammar, whatever given here, I am taking the same grammar. Don't disturb, go. Don't disturb. Okay. Every time we have to start from start symbol. Okay. Here, S is the only symbol. So we must apply the production in S place. S has AB, the production. Okay. Now, After this step, we can apply a production either in A place or we can apply either in B place. Are you following? Hello?
Yes.
Okay. But in this, what is the leftmost non-terminal in these two? First, S is the symbol. We have applied AB. After this step, we can apply in A place or B place. But in these two, which one is the leftmost non-terminal?
A.
A. So every time, so in A place, I am applying this production AA. Okay. Now, here this is the string. Again, we can apply in A place or B place. But every time, if we apply a production to the leftmost non-terminal only, I repeat, here we can apply in A place or B place. We can apply in B place B productions or A place A productions. But in these two, here the leftmost non-terminal is A. If we apply every time a production to the leftmost non-terminal only is called as LMD, leftmost derivation. Now, in A place, I am applying this production A. Okay, now it is. Now, what is the leftmost non-terminal? This is the only non-terminal, that is the leftmost. And I am applying in B place B. So, this is called leftmost derivation. Here I repeat, S is the only symbol. So, when only one symbol is there, either we can consider it as either leftmost symbol or rightmost symbol. Okay, suppose in the queue there is only one person. If there is only one person in the queue, that person is the first person and that person is the last person. Okay, like that. When S is the only symbol, S is the leftmost symbol as well as rightmost symbol. I am considering this as leftmost symbol and its production AB. Now A is the leftmost symbol, AA. Here A is the leftmost symbol, its production, and B is the leftmost symbol, its production. Okay. Now its derivation, whatever we did, we can represent using the trees. That is, yes, there is AB and A place AA and A place A and finally B place B. So here the string is A, B from left to right, taking the leaves. Okay. So take the definition in your notes. Take the heading LMD. Okay. If we apply a production, every time to the leftmost non-terminal only, is called as leftmost derivation, simply LMD. Okay, take this grammar and that example. Rightmost derivation. Take the definition. Hello, here did you copy this derivation and grammar?
Yes,
Yes, sir.
LMD. Okay, have you copied this one? Okay, now take the definition for RMD. If we apply a production every time, to the rightmost non-terminal only is called as RMD. Okay. Every time we must start from S. S is the start symbol, and here this is the only symbol. This time I am considering this as rightmost, and its production is AB. Now we can apply in A place or B place, but if we follow rightmost, as B is the rightmost symbol I am applying a production for B. In B place, I am substituting B. If it has two productions, one is BB and B, I am substituting here B. Now A is the only symbol, so it is rightmost, and its production I am applying as AA. Now this A is the rightmost, as only one is symbol, so I am applying in A place A. So this is the string. So whatever the string we derive, that derivation can be represented using trees. First we have taken S and its production is AB. After that, in B place we have taken B. After that, in A place we have taken AA. After that, in A place we have taken A. So even though it is rightmost derivation, in the tree format, the string can be read from left to right only. What is the string here? A, B. What is the string? A, B. Okay, so this is the rightmost derivation and its corresponding tree. Okay, now copy this derivation and derivation tree. I have dictated the definition. If we apply a production every time to the rightmost non-terminal only, is called as rightmost derivation. Now take this example. The same grammar, for the same grammar and for the same string, we have done RMD. Okay, done? Completed?
Yes, sir.
Okay. Guys, look at this. This is leftmost derivation. We have applied to the leftmost non-terminal. Whereas this is rightmost derivation. And definitely this derivation and this derivation not same. One is LMD and the other one is RMD. These two derivations are different. No doubt in it. Whereas this is the parse tree for the leftmost derivation. And this is the parse tree for the rightmost derivation. And look at these two derivation trees, or look at these two parse trees, this and this. Are they look same or look different? Are you following? Even though here the derivations are different, one is LMD, the other one is RMD, how their trees look? Their trees are look same. Yes or no? Do you find any difference in these trees? Don't say. Yes, sir, difference is there. One is blue and the other one is orange.
Sir,
Okay. So the trees are looking same. So even though derivations are different, the trees are not different. Trees are same. Okay. Now here a concept ambiguity will come. Ambiguity. Now here the string is in the two derivation trees, the two parse trees, the string is AAB. Same string. If it has two different parse trees, here this is the one parse tree and another parse tree. If these two parse trees are different, then we can say the string AAB is ambiguous. Okay. So this concept I will tell you, but here the trees are same, so AAB is not ambiguous. Okay. That concept I will tell you.